Good morning, dear student. How are you? So, if the screen is visible to you and audible to you, please put a message in the chat box. Student of JNV Ramnagar, how you are doing? So, make a rapid response if there is no problem with the screen and audio. Okay, and then we will start the session. Okay, good to go. So, I welcome you all in this session of question discussion of simple harmonic motion, part 4. And this could be the last session of simple harmonic motion because we have discussed each and every type of question that is possible from this chapter. Okay, and today is the last session, so we are also going to see PYQs as we have move on. Yeah, good morning. How are you? So we will move according to the trend that we are moving on from the previous classes. Firstly, we will discuss some of the concepts and then we will move further with the numerical part. Okay, now, so concept revision, I think all the concept I have covered completely related to SHM. Few, a very few are remaining, and that is just related to the competitive point of view. Okay, so we are going to see them one by one, and you just have to note the formula because in JE and NEET, basically from these concepts, only the formula based question has been asked. Okay, so let me start with the first concept. So concept first here is when a cylinder is dipped in a liquid, so time period of that cylinder would be, because when we dip this cylinder and press it, so it will oscillate because of the buoyancy force. Okay, so we can say that time period, because it is oscillating, so time period of that oscillation is given by 2 pi root m upon a rho g. Okay, where where m is the mass of cylinder. Okay, rho is the density of liquid. Okay, and a here is the surface area of the cylinder. So this space would be like this. This is the cylinder we have, and it is partially dipped inside the liquid, and when it is oscillating to and fro. Okay, so the time period of oscillation is given by 2 pi root m upon a rho g. Okay, why this is oscillating? It is oscillating because of because of what kind of force is acting here? First is the weight mg, and second is the fb, which is the buoyant force. Okay, buoyant force is the force here which is responsible mainly for the oscillation. So because of buoyancy, or fb, you can see buoyant force. Got it? Now, in this case, we have various situations. We can modify this. Like if this is a ceiling here and we have a spring, and then we attach this cylinder with the spring, and this cylinder is partially dipped inside the liquid of density rho, then what would be the time period? What would be the time period? So we can say here the spring constant is k. Okay, so this a rho g here in the case of oscillating cylinder, in the case of liquid, this A rho g is the effective spring constant. I have already told you in the previous session that time period is given by 2 pi. On the numerator, we have inertia factor, and in the bottom side, we have a spring factor, or you can say the elastic factor also. Okay, so this cylinder is oscillating, which means it is moving away from its mean position and going back to the mean position because of the FB. Okay, so that is why the spring factor here will be FB, and FB is given by A rho into G here in this question. Now, A rho here is the immersed volume. Got it? And G is the gravitational force. We know that. Now, so in this case also, you can consider it that two springs, if you consider the liquid, the buoyant force as a spring force, which is acted by this liquid on this cylinder. So you can consider that there are two spring attached of spring constant K and K dash. And the K dash here is given by this liquid. Okay. So time period, effective time period here will be 2 pi mass of the cylinder divided by spring factor, which is A rho G plus K. So remember it. This is very important. Okay. And this is also. This is concept 2. This is concept 1. Okay. Try to take the notes. It will be really helpful to you. So I hope you have noted down. So moving next, if in the same situation, I am going to tell you the core of oscillation. Okay. Now, if the ceiling is same, the spring attached is same, and the cylinder is also same, but there is only one change in the situation. Now, this cylinder is completely immersed in the liquid. Okay. Now this cylinder is completely inside the liquid. Now what will happen? If you have noticed from the beginning of SHM to the end of it, we are almost in the end of it. So if you have just noticed one thing, that whenever we are writing the force which is responsible for oscillation, condition for oscillation, we have written that F is equals to minus of kx raised to the power n. This is for oscillation. And this is k into minus x raised to the power n. And n is equals to the odd integer. Odd integer. Now, what the fact here is that this force is depends somehow on the displacement. In case of SHM, in SHM, this n is equals to 1. So force here will become minus kx. Now, who is going to tell me that this force is a constant or a variable force? Obviously, this k is constant, but this x is not. This x is the displacement from mean position, and it is changing in SHM each and every instant of time. So this force here that we have, F is equals to minus kx, is nothing but a variable force. This is a variable force. Okay. So in SHM, only the variable force is responsible for the oscillatory motion or SHM. Okay. Or you can say in the other word that SHM is only possible because of the variable force. All the cases that we have discussed till so far, we have discussed the spring block system. Okay. We have seen it. In spring block system, when we place it vertically, then we consider mg there, mass of the block. But mg is a constant force, and that is why it is getting cancelled in the expression, and you have seen nowhere the mg force. Okay, have you seen it in the horizontal arrangement of spring block system and the vertical arrangement of spring block system? We never ever have mg because mg is a constant force. And for oscillatory motion or for SHM, special case of oscillatory motion, in SHM we only have the variable force, or SHM is only possible because of the variable force. Got it? So that is why when we immerse this complete setup, not complete, only this cylinder inside the liquid, then what will happen? The buoyant force now, FB, will become a constant force. Okay. So in this case, FB become constant. Why? Because FB is given by density of liquid, volume of solid immersed, multiply G. Now the complete volume is immersed. Okay. So when this cylinder is completely inside the liquid, there is no change in the volume immersed. So that is why this FB now become constant. And if FB is constant, so in the oscillation, it will not come into the expression. So we can write the time period for this situation. Time period here is square root of what? Inertia factor, which is mass of the cylinder, divided by now A rho G. You will not have here. It is simply m upon k 2 pi. Okay. So this you have to remember, that you need to only consider The force which is variable, not the constant one. Got it? Now, another important expression here that I want to discuss is the concept of, third concept we have, when a pendulum, when a bow of pendulum is dipped inside a liquid of density rho and bob has a density capital D. So what will be the effect on time period of this? So directly you need to learn the formula, because when this complete setup is immersed inside the liquid, so what will happen when this oscillate? This G here is not only G, because the buoyancy force will decrease the value of G. So the effective G we have to take. This is a buoyant. So effective G we have to take. Got it? I am not saying that I am considering FB as a variable force. No. But FB constantly reduces the amount of G. Okay. So that is why the G effective we have to take in the time period of simple pendulum. So time period initially was given by 2 pi L upon G. But in this case, G is not itself G. G become G effective. And now how to calculate this G effective? So G effective is G into 1 minus density of solid divided by, sorry, this is G upon N, you can say initially. And what is N? So N you can say 1 minus density of solid divided by density of liquid. Okay. So you can put it here and you can calculate. Got it? So G, the value of G you will see here will reduced. Okay. Now, this is the thing that I want to tell you. Move on to the first question. And that is, I have given you as a homework. So have you did it? And if you have did it, what is the answer? Please comment. Meanwhile, I'm solving. Now, the general displacement of simple harmonic oscillator is x is equals to a sine omega t, and let t be its time period. The slope of its potential energy ut curve will be maximum when t is equals to t capital T upon beta, where capital T is the time period. The value of beta is, now in this question X is given to you as A sine omega t. Okay. Now, we know that potential energy is nothing but 1 by 2 kx square in general. Okay. So what we are going to do, we will put the expression of x in this potential energy expression. We have 1 by 2k x square will be a square sine square omega t. Now the slope of potential energy and time curve, which means a curve between u and t. Let's say somehow it is a curve like this. So what will be the slope of this ut curve? The slope of this ut curve will given by du by dt. No problem in that. Slope of vt curve, speed time curve, slope of velocity time curve is given by dv by dt, which is nothing but acceleration. Okay. The same concept we have applied here. That slope of ut curve is given by du by dt. Now differentiate it with respect to time. So du by dt. Now I'm using d, not del, because this expression is completely in complete the function of time. But as we have discussed wave, in that scenario, the expression itself hold with a variable x also. Depends on position also. So du by dt is 1 by 2 k a square is constant. Sine square omega t firstly will be treated as x square, and the differentiation of x square is 2x, which means 2 sine omega t dot. Now we have sine omega t as a function. Sine omega t differentiation will give you cos omega t. Okay, cos omega t. Now omega t itself is a function here. So when you differentiate omega t, it will give you omega. So du by dt you have as 1 by 2 times k omega a square 2 sine omega t into cos omega t. It is a trigonometric formula. 2 sine theta into cos theta gives you sine 2 theta. Let me write it here. Sine 2 theta 2 sine theta and cos theta. So we can write this 2 sine omega t into cos omega t as 2 sine omega t. Sine 2 omega t. Got it? Now this du by dt will only depends on this sine 2 omega t factor. Read the question again. The slope of its potential energy curve will be maximum. When will be this maximum? This will be maximum when this sine omega t 2 omega t will be maximum. Sine 2 omega 2 will be maximum when it has a value of 1. Got it? So we can say that sine 2 omega t should be equals to 1 for du by dt to be maximum. Got it? Now sine 2 omega t equals to 1. Sine 2 omega t equals to pi by 2. This is the value. Sine 1, sine theta is equals to 1, which means theta is pi by 2. Now 2 omega t, this is sine pi by 2. Just a second. This sine pi by 2. So 2 omega t equals to pi by 2. Now omega you can write 2 pi by capital T into small t. pi by 2. Pi and pi will cancel out each other. This will become small t here is 2 to the 4, and this 4 will multiply this 2, so it will become t by 8. Now, in the question that is given that t is equals to t upon capital T upon beta. So if you compare it with this, so beta that you have is 8. Okay. So this is the answer. I hope you have got it and you have did it also as I have given you as a homework. So beta has a value of 8. Now move on to the next question. Now try to solve this question. I'm giving you 1 minute to solve this question. The bob of pendulum was released from a horizontal position. The length of the pendulum is 10 meter. If it dissipates 10% of its initial energy against air resistance, the speed with which the bob arrives at the lowest point. Very conceptual question and easy question, I will say. Try to solve it down and tell me the answer. A, B, C, or D. Okay. Keep solving it. Okay. So we have a bob here. Let's say this is the position and this is the lowest position that it has. And it has been released from a horizontal position, which means from here it has been released. Here to here it has to come and it dissipates 10% of its energy against air resistance. Now, if you will see, this is the maximum possible situation that it can have. Extreme. This is the extreme you can count. Okay. Now, at the extreme point, what will be the energy that you have? Okay. Let's say the total energy is capital E at the extreme point. And this is nothing but potential energy, because when you are releasing it, so when you release this ball, you have released it with zero velocity, which means all the energy that it can have at this horizontal position is potential energy. And we have a 10% loss. So total energy will be decreased by 10%. Total energy decrement means potential energy is somehow decreased by 10%. Okay. So let's say what is the decrement? So total energy that you will have to now is E dash is E minus 10%, 10 upon 100 into E. So it will become 90 upon 100 into E. Got it? And this E is nothing but the potential energy, because here the total energy itself is potential energy. There is no kinetic energy. And 10% we have lost it. So remaining of it will be converted into kinetic energy of the system. So this energy 10% we have lost, we do not have count on it. But this 90 by 100 into E, this will completely convert it into the kinetic energy, because at the lowest point we have V maximum. Maximum velocity mean if I take the reference line this, so here also if you go by according to this reference line, so bob at the lowest position on its mean position, so the potential energy is zero. Okay. So if the potential energy is zero, all the energy that we have in terms of potential energy is converted into the kinetic energy. And how much energy that we have? We have only 90 by 100 into potential energy, because 10% we have lost. That is not recoverable. That is not convertible. So this 90 by 100 into potential energy, E you can take as U, will be converted into 1 by 2 mv square. Now, the potential energy at the horizontal position will be mg into L. This length is L, mass of the bulb is m, let's say, and g is the gravitational acceleration. So 90 by 100 ko you can write 9 by 10. M into g into L is also given to you 10 meter. 1 by 2 m into v square. Now m and m will cancel out. 2 will cancel out this. 2 5 ja 10. 5 2 ja this. So v square that you will have here is, just a second, 9 into 2 is 18. Got it? This is mg. G is also we have, so we have 1 0 extra. So v square will become, v will become square root of 180. Square root of 180 you can write as 6 root 5. If you take it inside, so it will become 36 into 5, which results in 180. And 36 is the square of 6. So we can take 6 out, and it is root 5 inside. Meter per second. Okay. So this is the correct answer. Option number D. Got it? I hope you got it. Any kind of doubt, if you have, you can ask. Okay. Now move on to the next one. This. Try to solve it down. A ball is suspended by a thread swings in a vertical plane so that its magnitude of acceleration in the extreme position and the lowest position are equal. The angle theta of the thread deflection in the extreme position will be, that you have to calculate. And given that the acceleration at extreme position and acceleration at the lowest position are equal. Got it? Now, try to solve it. Let us consider that this is the bob, and let's say this is here. This is the extreme position of a bob, and this is the lowest position that it achieved. Okay. So acceleration at the extreme position is equals to acceleration at the lowest position. This is the thing that is given to you. Now, We will consider that length of the this string is L, mass of the orb is M. Okay. So we will draw the forces. This is mg. Let's say this angle is theta naught, which is the extreme or angular displacement, you can say, angular amplitude. Okay. So this will be mg cos theta naught, and this will, let me draw this here to make it very clear, because we're going to need this mg cos theta, mg sin theta. So I'm drawing it here. Okay. Now this is the bow in both the situations. This length is L, mass is M, so mg. This is the angular amplitude theta naught at extreme position. So this will be theta naught. So this component will be mg cos theta naught, and this component along the tangent to this circular path is mg sin theta naught. Okay. There will be a tension in the string here, T. Okay. Now, if you closely analyze these two positions, first is the extreme, second is the lowest. In the lowest position, there will be a tension in this, and mg is the force. Okay. Now, if you will see at the extreme position, the force which is responsible for the movement of this bow is mg sin theta. Because this mg sin theta, the component this mg sin theta is only responsible for the torque generation, because this is the perpendicular to the point of rotation, and this mg cos theta and tension is passing through the point of rotation or the axis of rotation. So they have zero torque, which means they are not responsible for the acceleration at this point. So acceleration here is only came from the tangential component of force. So at extreme position, I will write first is at extreme position. At extreme position, the force here is mg sin theta, and which is equals to ma. So acceleration in this case is g sin theta. This is equation number 1. Okay. Now in the lowest position, there is no tangential component. If you try to resolve the mg, the tangential component will be at 90 degree, will automatically results in 0. So there will be no tangential component, which means here the acceleration is came from directly the centripetal acceleration. So in the second case, at the lowest position, position, acceleration is coming from centripetal acceleration. So we will write that T minus mg is equals to what? mv square upon L. This is equation number. Okay. So what we are going to do, we have to equate, because from this equation, we are not getting the value of acceleration here. Okay, got it? So what we can do, we will somehow get this value mv square upon L. And this we can only be able to get from the energy conservation, as we have seen in the question discussed in the yesterday's class. Okay. So let's say this length it has, so it will be L minus L cos theta naught. I have discussed in the previous class how to get it. So in this extreme position, it has only potential energy, and in this lowest position, it has only kinetic energy. So we can equate it that L minus mg L minus L cos theta equals to what? Mg, sorry, 1 by 2 mv square. Now, from here you can say this mv square upon L is the acceleration. So this mv square upon L we can make here mg 1 minus cos of theta equals to mv square upon L. We have take common this L and divided with this mv square. Okay, and this 2 will come. Now this is the acceleration at the lowest position. This is the acceleration at the highest position. So what we are going to do, because it is given in the question that acceleration at lowest position and acceleration at highest position or the extreme position is equal. So acceleration at extreme position is g sine theta, which is equals to this mv square upon L, and sorry, v square upon L. So m and m will also cancel out. So we have 2g 1 minus cos of theta. G and G will also cancel out. So you have sine theta divided by 1 minus cos of theta equals to 2. Okay. So now sine theta upon 1 minus cos of theta equals to 2. So sine theta we can write 2 sine theta by 2 cos theta by 2, and 1 minus cos theta you can write that cos 2 theta equals to 2 cos square theta minus 1, and another formula is cos 2 theta equals to 1 minus 2 sine square theta. So 2 sine, we can make 2 sine square theta 1 minus cos 2 theta. So it is 1 minus cos theta. So we can write 2 sine square theta by 2. 2 sine square theta by 2 equals to 2. 2 and 2 will cancel out. Sine theta by 2, theta by 2 will cancel out. So you will have here tan theta by 2. You are wondering how I'm writing cos theta by sine theta is tan theta. So answer is here. This is the way. We have inverted it. So if you invert it, you will get tan theta. Now, this is theta naught. So theta, let's say this is theta only. So theta by 2 you have as tan inverse 1 by 2. So theta you will have as 2 tan inverse 1 by. So this is the maximum deflection, or this is the deflection at mean position. Okay. This is the deflection at mean position. Sorry, at extreme position. So theta that we have here is, so from here we can say theta is 2 tan inverse theta by, sorry, 1 by. So 2 tan inverse 1 by 2, which means option B is the correct one. Option B is the correct one. Now do this. I have just discussed this concept with you. Try to apply it and get the answer. This pendulum is dipped. A simple pendulum oscillating in air has a time period of root 3 seconds, And if it is completely immersed in non-viscous liquid having density 1 by 4, non-viscous, why is he saying? Because if he's saying that this liquid is viscous, so you have to consider the viscous force also. Having density 1 by 4th of the material of bob. Now the new time period will be. So I have told you that T initially it's given by 2 pi root L by G, but T after dip, T it immersed position is given by, and let's say we will consider it as T dash. So T dash is given by, I have told you, L upon G effective. And how to calculate this G effective? G effective is G by N, and N is nothing but 1 minus density of material, which is given by capital D, by density of liquid. And here in this question is given that this liquid having a density 1 by 4th of the material of both. Okay, got it? So we can say that this d by rho is nothing but 1 by 4. So n will be 1 minus 1 by 4. Okay, n will become here 3 by 4. So g will become g upon n, which is 3 by 4. Just a second. This is, I have made a mistake there. It is, I think, rho by d. D upon rho, which is given here that liquid density is 1 by 4th. If liquid density is rho, this rho is 1 by 4th of d. So if you take the ratio, this n is getting negative, which means we have made a mistake here, that it is, I think, d by rho by d. It is rho by d. That is why it is coming as 1 by 4 into 4 minus 1, 3 by 4. And this is Ng. That is why this will become 3g upon 4, which is the reduced value. Okay. So T is equals to 2 pi T dash. You put the value of G here, G effective. So T dash here is 2 pi L upon 3g by 4, which is, oh, just a second. Give me a second. I'll just check and confirm the this to you. Okay. Meanwhile, you will solve it if you have the answer in your mind. Just give me a second. Are you solving it? Try to solve it. So correct value here is, just a second, and I'm going at the starting of this tab, where I mentioned it this way. So G effective is G minus G upon N, and N here is the only D by rho. That is the correction. Okay. I'm just confused with where to have minus here. So D by rho is the only thing that you have to do. Now, if you apply, so N you calculate is D by rho. D is the density of the bow material, and rho is D by 4, 1 by 4th of the material of bow. So this will become 4, N equals to 4. Now G effective is G minus G upon N, G minus G upon 4. So this will become 3G upon 4. Okay. Now, this time period T dash is 2 pi root L upon 3G upon 4, which becomes 4 by 3G. And you can take this as common. So this will become 2 upon root 3 into 2 pi root L by G, and which is given to you root 3 second initial time period. So when you put it root 3, you can cancel it out. So the time period effectively that you have is 2 seconds. Okay. So the correct option here is 2 seconds. Okay. So this is it, guys. We are almost up with the time. So यहीं तक रखते हैं. Any kind of doubt, if you have, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive, student of JNV Ramnagar and other students also. Thank you so much for being attentive. Okay. Keep on studying. Take care of yourself. Bye bye.